Hello everybody, this is me again, Yusuf Saleh, chemistry teacher, and in this mini lecture we're going to give the answers to section 2-3 revision, which is the third section in chapter 3. So as we repeated many times, read the question more than one time, and actually 3 times will be perfect in order to avoid any misunderstanding. So let's move to question number 1. Question number 1 says the density of copper is listed as 8.94 gram per cubic centimeter. Two students each make 3 density determinations, which means they made tests to determine the density. Of course, they don't know that it's copper, because if it would know, they would find it from the lists or from tables. Anyhow, other sample of the substance. Student A, the first student found the results registered here. So one of the results 8.3 gram per milliliter. The second 9.4 gram per milliliter. The third is 8.3 gram per milliliter. Okay, this is the first one. You can see that these results are far from the given one, and these are also far from each other. The second one, the student B, registered the results 8.4 gram per cubic centimeter, 8.8 and 8. They are a little bit close to each other, but are they close to the accepted value? Let's see the answer. The answer, student A results not accurate. Why not accurate? Because they are far from the acceptable value, far from the real value. Okay. Are they close to each other? You see, they are not close to each other. So the first student A, the results are not accurate and not precise. Why not accurate? Because they are far from the real value, from the accepted value. Also not precise because they are far from other also. Let's see the second. The second, the results are close to each other. Okay. Say student B. Student B has results accurate because the average 8.40 is more precise than student A. So actually here they are the more precise and more accurate than these results here. Low accuracy and low precision. But here we have more accuracy and more precision. Why more accuracy? Because in average, the results are closer to the acceptable value. And they are close to each other also. So they are more precision and more accuracy from student A. Let's move to question 2. Determine the number of significant figures. Okay, we have the rules of significant figures. Keep them in mind. We said all non-zero digits are significant. Zeros to left are not significant. Zeros to right are significant. So I mean, the zeros to right and to right of the decimal are significant. And the zeros to right of the non-zero to left to the decimal are significant if they are measured, but if they are estimated, they will not. So we will keep these rules in order to decide how many significant figures we have. And the first one we have, okay, the first one we have 6.002. The two non-zero digits are 6 and 2, and the zeros between non-zero digits and between significant are also significant. So we have here how many? 4 significant. Why? Because all the zeros between the non-zeros are also significant. The second, we have 0.0020. The zero to right is significant, but the zeros to left are not. So we have only these two are significant, so we have two. Second, we have 10.0500 grams. Okay. The zeros between non-zeros are significant. The zeros to right and to right of the decimal and to right of non-zero also are significant. So that's why all the digits here, all the numerals are significant figures. So we have here 6 significant figures. Okay, in D, we have 7,000 kilograms without point, and we have 7,000 kilograms with point. What does the point mean here? The 7,000 without a point means it's estimated. The zeros are estimated. The estimated ones are not significant, but here they are measured. They are measured. The measured are considered as significant, but the ones estimated without point, decimal point. So here we have only the 7 is significant figure, but here we have all of them are significant figures. So let's move forward and see question 3. Okay. And question 3, it says round 2.6765 into two significant figures. Okay, 2, which means we must reach here. So we have the 7 here, the 7. Would it increase the number to left or would it not? 7 is greater than 5, so it must be added. So the 6 will become 7, so this will be 2.7. The digit here is greater than 5, so this must be added. Okay. Second, we have carry out the following calculations. We have some calculations here. Let's see them and solve them. A, 52.13 grams plus 1.7502 grams. Okay. This is addition. And addition has its own rules. Let's see. When addition or subtraction, the result must be rounded into number of digits to right of the decimal equal to these present in the fused one. So we have two given data, two given measurements. In these two given measurements, in this one, we have 2 digits, but here we have how many? 4 digits. So you must round the result into a number that contains 2 digits to right of the decimal. Here the result contains how many? 4. So we must move the the rounding must remove the 0.2. Of course, nothing added to 88. Why? Because there is 0, right? Because there is 0, right? And it is less than 5. Whenever we see less than 5, nothing changes. Just remove it. Okay. This is about addition. Let's move if we make a multiplication. And multiplication, we have also rules. The rules say that the result must be rounded into a number of significant figures equal to these in the least measurement. So which one contains the least significant figures? We have 12 meters times 6.41 meters. This has 2 significant figures and this has 3 significant figures. So we must round the result into 2 significant figures. Let's see the calculation. The calculation says the result is 76.92 meters square, rounded into 2 digits. Why 2 digits? Because the least measurement, or the measurement contains least significant figures, is the 12, and it contains only 2. Okay, so 79.6, as long as 9 is greater than 5, so the one to left, the digit to left must be increased by one number. So the 6 becomes 7, and the result becomes 77 meter square. Okay, we have C is division. Division is like subtraction. The result must contain number of significant figures equal to the measurement, or at least the measurement with the fewest significant figures. So we have here, how many significant figures? We have 4. Here 4 significant, and here we have how many? We have 5. So the result must be rounded into a number that contains 4 significant figures. The calculator gives us this result. And how many figures here? Many of them. 1, 2, 3, 4, 5, 6, 7. And we need only 4. Why? Because the least has 4. So rounded into 4 significant figures, it became 3.159. And we saw that the 8 is greater than 5. So, to 4 significant figures. So the 8 is greater than 5, so increases the 8 here into 9, so it becomes 3.159. Okay, let's move to question 5. In question 5, actually some questions are repeated, so sometimes you need to try it by yourself in order to save time. It says perform the following operations, express each answer in significant figures. In scientific notation. We know the scientific notation is Mantessa, a number between 1 and 10, less than 10 actually, times 10 power to some exponent. This exponent can be negative or can be positive. So let's see the question 1. Okay. Or A in question 5. We have this measurement 1.54 times 10 power negative 2 plus 2.86 times 10 power negative 1. In previous lesson, we said that when adding or subtraction of scientific notation, we must get the exponents equal first. So we have negative 2 and negative 1. We have 2 options. Get the negative 2 equal to the negative 1, or get the negative 1 to the negative 2. Both of them are correct. Both of them are correct. But I think it's better to get the less one into the more one. So we have the less one is negative 2. Let's make it negative 1. Okay. We can also solve it by vice versa. So we're going to talk about both methods, both techniques, and let's see the solution. First, make the exponents equal. As I told you, I prefer to have the negative 1, negative 2, of course, negative 1 to negative 2 to negative 1. Why? Because it saves steps, so one step will be saved here. Okay, so when we change the one given here, when we change it into negative 1, the exponent is increased by 1. So the decimal will move, this decimal will move rightward. Why? Because we have increased it. If we decrease this into negative 2, the decimal will be moved between 8 and 6. But as I told you, it's better and shorter to maximize, which means to increase the exponent of the least one. And here, negative 2 is less than negative 1. Okay, now, sorry. So here we have get it the 2.86, it's the same, but the 1.54 times 10 power negative 2, we made it negative 1. Now we can make the addition. Of course, after adding by calculations or even manually, we found that the result is 3.014 times 10 power negative 1. Negative 1. Okay. Here, in addition and subtraction, we said the numbers or the digits to right of the decimal must equal the ones present in the measurement that has fused. The measurement has fused in the question here. We have 2 here and also we have 2 here. So the result must have 2 digits to right of the decimal. But in the, what about the result? The result has 3. So we must get it 1. And the 4 is less than 5. 4 is less than 5. That's why we can remove the 4 and nothing will change for the 1 here. So it can be rounded here. We're going to remove the 4 and nothing will be added to the 1. So the result is rounded into 3.01. 3.01. We have B is homework. Why? Because you must have some practice actually. Beside B is very similar to the previous one. C. C we have multiplication. Yes, multiplication. In multiplication with scientific notation, we always said that the exponents will be added. When multiplying, the exponents are added, and we will have the result with number of significant figures equal to the measurement that contains less, which means the least. So we have 2 measurements here. The 2 measurements, 8.99 times 10 power negative 4 meter times 3.57 times 10 power to 4 meter, which means the result must be meter square. But when we multiply, we're going to multiply the first mantessa with first mantessa. So we're going to multiply this by this. Okay. The result here, let's say this is question mark. And the question mark, sorry. Okay. Now, the question mark times 10 power to the first mantessa minus this, plus the second, which is negative 4 plus 4. Of course, it equals 0. So 10 power, any number, if the power is 0 equals 1. For any number, if the power equals 0, the result is 1. So we will, as we said here, the result here is, the result of this times 10 power to 0. 10 power to 0. So this equals 32. Here, let's say this equals 32.0943. Of course, we can remove the 10 power to 0 here. Why? Because it equals already equals 1. Okay. Now, the result. Sorry. The result here must be rounded into number of significant figures equal to the decimal that contains the least. We have here three significant figures and also 3 significant figures. So we must round until we reach this place. We have 9. So 9 adds 1 to left. Why? Because it's greater than what? Greater than 5. So we have 0, it becomes 1. So the result is 3.21 times 10 power to 1. Of course, the unit is meter square, as written here. Okay. You can see that the answer here has three significant figures equal to the ones present in the fewest. Actually, both of them are the same. So no this and no most. About D, D is similar to C. That's why it's your homework. Let's move to question 6. Question 6 says write the following numbers in scientific notation. How can we convert a number to scientific notation? If the number has many digits to left of the decimal point, of course the exponent will be positive. If there are the digits, non-zero digits, and are to right of the decimal point, of course the exponent will be negative. Let's see how. It says here 560,000. Okay, where is the decimal here? The decimal here must be here. So how many digits we're gonna move it? How many locations in order to get the mantissa between 1 and 10 or between 1 and 9.9? So how many digits we must move? How many places? 1, 2, 3, 4, 5. Okay, so we will say 5 point, how many? 0.6 times 10 powered. We have moved leftward. We have moved the decimal leftward. So the exponent will be positive. How many places we moved? 5. So it is 10 power to 5. Okay. 10 power to 5. B is homework because it is similar to the previous one. Let's move to C. In C, we have also zeros, but the zeros here are not to left of the decimal. They are to right of the decimal. Of course, here they cause having a negative exponent. Let's see how. Okay. How many digits I must move? Let's write it again here. We have 0 point, we have 0.000. How many zeros? 3. 4, 1, 2, 0. This is much less than 1. We need to have the mantissa equal to 1. So we're going to move the decimal how many places? 1, 2, 3, 4. Okay. How many digits moved? How many places? 4 places. So here the result will be 4.20 times 10 power to how many? How many places we moved? 4. Okay. Did we move to left or to right? To right. So the exponent will be negative. We said 4. So it is negative 4. Okay. As I said, when moving the decimal point to left, the exponent is positive, and when we move to right, the exponent must be negative. As we can see here, it's negative 4. Okay. Let's move to question 7. Question: a student measures mass of a beaker, a glass beaker filled with corn oil, edible. The mass reading averages of, that's right. Okay. Sorry. 215.6 grams. This is total. This is total, which means this is the mass of the beaker with the corn oil. It says also mass of the beaker is 110.4 grams. Okay, A says, what is the mass of corn oil? Of course, the aim here is not to subtract the mass of the baker from the total mass. The aim and the target here is how to treat the result. How to treat the result? Of course, you're gonna subtract the mass of the baker from the total, and we found it equals how many grams? 105.1. But here we have to right of the decimal one digit. And in addition and subtraction, we have to get the number of digits to right of the decimal equal to these present in the measurement that has fused. Okay, how many? 1. And the measurement here, also 1. And the measurement here, also 1. So it is treated already. It is treated already, and it is correct already. Okay, B. B says, what is the density of oil given its volume is 114 centimeters? Okay, we found the density of the oil to be 105.1, and sorry, and the volume is given to be 114. Of course, the rule of density is always mass divided by volume. Okay, we have mass divided by volume, and the answer here, how can we treat the answer here? The answer here must be treated as previous rules. We have here division. In division, we must get the significant figures present in the result equal to these present in the measurement has fewest. Okay, in measurements we have here 4 significant figures and we have 3. So we must round this into 3 significant figures. So we must move to here. We have 9. 9 greater than 5. Okay, so this will increase the number to left of the 9 by 1. So here, actually, we have how many? 4 significant figures, so this must be here, sorry. Okay, because 2 is less than 5, we'll add nothing. Just remove the 29. Here it will be removed without adding anything. So as you see here, we have 4 significant figures, and this is compatible to the rules of the multiplication and division. Okay, let's move to the final one. The last one here is, sorry. It looks that not the last. Okay, what is the mass of gold occupies 5.0 times 10 power negative 3 cubic centimeter, and gold's density is given to be 19.3 gram per cubic centimeter. Gold is heavy, yeah, heavy and precious. Okay, so we have here the density. Okay, this is the density is given, and also the volume is given. We have a rule says that density equals mass divided by volume. Okay, and we need the mass here. So mass equals m equals, by cross multiplication we'll say it is density times volume, and density here is given to be 19.3, and the volume is given to be 5 times 10 power negative 3. So the result here contains how many significant figures? We have 3, and here in the least one has 1. So this must be rounded into 2. Also, you see that it is rounded into 2 significant figures. And the final question is, the last one is here the difference between a graph of direct proportionality and inverse proportionality. We studied that before, and let's do the 2 graphs in quick. Okay. The first graph of direct proportionality is like this. it passes, it's a straight line and passes through point of 0.0. This is directly proportionality. The second, the inversely proportionality, it's not necessary to be straight. It can be like this. And it is also not necessary to pass through 0.0 point. So this is the difference between directly proportionality, dP, and inversely proportionality, IP. I think we studied this before, and we studied all the details about the proportionality, the direct proportionality and inversely proportionality, and this is all about the section 3, chapter 3 revision. Thanks for listening and have a nice day.